All right, so I'm gonna look at Cerakoting some of the SLS PA12 parts that I've made. Cerakote adds an additional benefit. Obviously, it provides an additional coating, protective layer. It's strong, scratch resistant. I think what's nice about it with SLS parts could be that as they're naturally porous in a sense, kind of maybe a grainier surface, the Cerakote will help smooth that out. And at the same time, because the layers of the Cerakote are so thin, it doesn't interfere with the functionality of the parts as well. So I'm going to attempt to do this. Now, with Cerakoting, there's basically kind of four main pieces of equipment, I would say. Basically, you've got your media blaster, which is any sand blaster. Now, they say for Cerakoting that you need to use 100 grit of the sand or aluminum oxide. To make sure you prep the surface properly, it's etched properly. You can get a media blaster, a sand blaster on Harbor Freight for $180 new, but you can find them, on Facebook Marketplace, whatever, right, for a lot less. You need some sort of HVLP spray gun, airbrush gun, and as well as the paint. And of course, Cerakote sells a kit for about $180. That includes all the equipment you need to get started and some sample sets of paint. So I went ahead and ordered that. Then you need an oven. So the Cerakote typically for metal parts, you need about a 300-degree oven. For SLS PA12 part, I keep saying SLS, but probably just as a whole, plastic parts, if they can withstand temperatures up to 180 or more actually, then you can probably Cerakote them. So Cerakoting for plastic parts, they recommend curing it at around 150 to 180 Fahrenheit. So for an oven, instead of buying something or using a kitchen oven, I want to build something that I can, more of a portable one here in the shop. The parts that we do here, especially coming out of our SLS machine, it doesn't create big parts, so we don't need a big cavity. I just happen to have a cabinet, and I've seen a bunch of stuff online how to basically convert it to an oven. So that's really on this is I'm going to show you. So the first step really is going to be me showing you the oven that I plan to build. So we'll step over here and look at this picture, and I'll kind of walk you through some of the design considerations when doing an oven for a Cerakoting. All right, so the cabinet I have, it's an old garage cabinet, very thin-walled, and it measures 24-inch width, 12-inch depth, and an 18-inch height. So it's approximately 3 cubic feet of space in here. And so the plan, it has a couple doors on it. I'll only show one door here. So the plan for a Cerakote oven is, you see most of the stuff, they use a polyol type thermoform backed with a foil board that will line that. So some sort of thermal board to line the top bottom sides. So that's the first thing. Most of this stuff can withstand up to 300, they say. So this is one of these where 180 will be fine. I'll use some foil tape to the joints. And the thing about foil tape is the tape itself, the aluminum tape, can withstand pretty high temperatures. The problem is the adhesive backing on that. So it can't get much over 200, and it could start deforming. So that could be a problem if you want to try to do anything other than plastic parts in this oven. All right, my plan is to install a ceramic heater down here on the bottom, and I think I've got about 1,000 watt one I've looked at. Should be plenty for this space. In fact, probably more than enough. The reason I ordered this, it's a ceramic curved heater. The reason why I ordered it was mainly because if I want to go to a bigger oven, I could use that and just replace this with something else. So you really want to mount that to a deflector plate of some sort, and you don't want it, I'm going to use stainless steel and put some legs on it here that holds it in place. And the reason why stainless steel, you get good reflectance, but it's also doesn't conduct very well. So anything touching this aluminum foil or aluminum on the sides that really I don't want that heat transfer. So that's the biggest thing. So I've got a PID controller, and I'll build an enclosure so that PID will be up here somewhere. Also, too, in most Cerakote ovens, you want some sort of airflow, convection airflow, because what happens is if this 1000 watt heats up, all your heat's kind of concentrated in one area, and I'll probably put some sort of bar through the side of this that hangs stuff on. And the problem is if you've got this heating up, you're going to have hot spots and some issues around that, and depending on where you have your thermostat, it may not necessarily, your whole chamber may not be even. So I need some sort of airflow. And what I have here is I do have I have an old 80 millimeter 12 volt DC fan, and so I think that will fit in here, this fan. And I'm going to have to mount this here, maybe some ducting, and really I only need about an inch of ducting because of the thickness. And then really I want to put some sort of baffle on the end of this that directs the air towards the back, up into the back wall, because what happens is as you flow, I want this air to move here, heat up, and flow through, and you basically get this flow through here. And that way, and I'll put the thermal probe probably somewhere here in the top left. And that thermal probe, that way this should be technically probably one of the coldest spots in the oven. So if this heats up to that temperature, then technically I think our overall oven should be fine. Now I am going to design, I think that this fan will be mounted on the outside by some sort of plate and in the inside, and I actually think the baffle part I'm going to print in the PA12 SLS. It can withstand obviously extreme high temperatures before it softens. 180 is more than enough safe for that. So that's, and then like I said, I get a PID controller. It's important that you keep constant control and stay within that plus or minus few degrees of the temperature. You don't want any runaway temperatures in here. So probably mount some feet on this thing here too, because I think the leads that come out of this, I'm gonna have to run across the bottom, and the enclosure box will be somewhere, probably sit up here. So that's kind of my design concept for an oven, and then I'll just show you then when I get to the process of getting this lined and adding the parts to it and kind of walking you through. I don't want to, there's enough online on this. I just kind of want to give you my basic concept on why I'm designing it this way. I think we've got a good concept here, and since I have a lot of this materials already, you know, we're probably under a couple $100 here to build this. So that is the next step.